So hello again. I am Roger Kochbar, and this is Week 1, Segment 8. In this segment, we talk about electric potentials as compared to voltages. This is an issue of terminology, or in the way I was saying it before, an issue of rectification of names. Sometimes people talk about potentials, sometimes they talk about voltages. It's nice to know what they're talking about. It's not quite the same thing, even though both are in units of volts, which makes it even more confusing. The confusion comes up when people begin to talk about a set of potentials as compared to a set of voltages. In other words, you've got a list of numbers. And what do you make of this list of numbers? So a set of potentials, people call it that, if all of the measurements are against a common reference point. People like to describe the common reference point as being at infinity, because conceptually it's nice to think of the common reference point as being a long way away and thus not affected by being in any particular place. That doesn't have to be true. The common reference point can be anywhere, but it is at some particular place, and all the potentials are measured against that common reference point. Now, in contrast, a set of voltages is measured in independent pairs. Each voltage is a different measurement than the other voltages, and so they don't have any special relationship to each other. So if you have a list of voltages, that's what you've got, a list of voltages, but there's no implied relationship. Whereas with potentials, there is an implied relationship because they're all measured against a common reference point. Maybe this becomes a little more clear with an example. Suppose I make this point my reference point. And now suppose I want to think about 3 or 4 other points. So I'll just draw me some points up here arbitrarily. Point 1, point 2, point 3, point 4, point 5. Now if I want to talk about the potentials, I will always take the negative lead of my meter. Here's my voltmeter. I'll take the negative lead and I'll attach it to the reference point. I'll take the positive lead and I'll go out to point 1. And what I'll get will be phi 1. Then I'll move the positive lead to point 2. And what I'll get, the measurement will be called phi 2. And I'll do the same for each of these in turn. What I'll get for the last point will be called phi 5. People normally use this phi symbol for potential, and it implies that the measurement is made against the common reference point. On the other hand, now suppose I want to talk about voltages. I might say, what is the voltage between point 3 and point 4? So I might want to put the negative lead on point 3 and the positive lead on point 4, and then I can get V 4, 3, maybe I want to call it that, equals phi 4 minus phi 3. That is, V43 is simply the voltage in between 2 arbitrarily chosen points. Here I happen to choose V43, 0.4 minus 0.3. Now the amazing thing is I can get V43 by subtracting phi 4 from phi 3, because you could say, well, what I've done is I have phi 4 minus phi 3. In effect, it takes away the reference point from the conceptual and the mathematical operation. So once I know phi 4 and phi 3, I can subtract them, and then I find the voltage between V4, 3. If I have now, suppose I have now V1, 2 in the same fashion, negative on 1, positive on 2. V1, 2 and V4, 3 have no particular relationship to each other. They're just two measurements that are made. There's nothing profound here in terms of bioelectricity. It's simply the terminology that's used. But because people go back and forth and they use it as if everybody knows it, I thought it would be worthwhile to take a moment and talk about it explicitly. So that's why I put it in this independent segment. Once again, we close with a picture of the Duke Chapel. Thank you for listening, and I look forward to talking to you in the next segment.